All right, so we're going to try to actually show the manual way to calculate double integration where you don't have a nice rectangle, you're picking any region. The process is going to be almost the same. I mean, you're certainly going to do the things in the same order. The change is instead of evaluating either the x or the y first, which you're still going to do, one of them is going to be a function of the other. So if we take a look here, we've got a little picture. This theorem here refers to the little picture over in figure 5.12. So if you've got a rectangular region and you've got some area D that's a subset of that region, so in this case, R is a rectangle down here. Um, D is a circular-ish region within R. Basically, you can set it up so that you've got a function g of xy equals f of xy when you're in the region, and it's going to be equal to 0 when you're outside of the region. That'll narrow your field. So you can sort of use the same basic premise. So we talked about this theorem below. We had a regular one for I think the weak form we had for the rectangles. Here we're going to have the strong form. So for a type 1, you're going to look at uh, the area of D, and you're going to break that up where you first evaluate the function of x. So you're going to evaluate y first, whereas the functions of y is a function of x, where g2 is strictly with greater than or equal to g1, which is greater than or equal to whatever your y is going to be from our previous video. But you have to evaluate the function first. So if you're doing type 1, you have to do the dy first. That goes in the middle. If you're doing the type 2 version, you have to do the dx first, because then you have those, and you're essentially changing your dx's into, you've already got a function of y, in this case h1 of y, h2 of y. You have to do those first, and then you go out from there. So let me do a couple of these problems, get you a feel for how they work. Number 80 here. So I'm going to do the inside. It's already set up. We've got the functions set up already, and we're going to be doing it. This is a type 1. So we're doing this, so we're evaluating with respect to y. So x is a constant, so that's going to be xy. Y squared, that will be y cubed over 3. And we evaluate all of that from 2x to 3x. So what we have here, we have, so 3x times x is 3x squared. Then we have 3x quantity cubed over 3, and that's minus 2x squared, and then 2x quantity cubed over 3. All right, let's clean that up a little bit before we try to take the next integral. All right, so I have 3x squared minus 2x squared will just give me x squared. That's, I'm looking at this here, remember the minus. And then I have 3x cubed minus 2x cubed over 3. And I should probably cube that out. So it's going to be 27 minus 8. And finally, what do we have, 19? And 19 and 3 aren't going to be divisible. 19 is prime. All right, so we're almost done. Now we're going to take the derivative of this with respect to x and evaluate between 0 and 1. So the integral of x squared, again, is x cubed over 3. And now we have an x cubed, which is going to be x to the 4th over 4. So then we have 19x to the 4th over 4 times 3 is 12. This is being evaluated from 0 to 1. The zeros are going to go away nicely, so we'll just put this in as 1/3 plus 19 over 12. 1/3 is 4/12, so this is 23 over 12.